Okay, it is recording, so you can begin anytime.
Okay, so hello everybody. Today I'd like to talk about the very interesting question, which is how does the CPU work? So, um, have you thought about this question at all, or does it sound interesting, or do you want to listen to it or anything? Uh,
Do we have a
so in any case, I should talk about this topic today. So. But let me start this presentation by asking you this question. What does the CPU do? Hmm? So, any ideas?
Yeah, doing the logical calculation.
processes?
Okay, nice tries. Like, yeah, actually, the whole thing is like it does some process, right? Like, so, what do you think? What do you think that like does the CPU think, or so like let's go emotional. Is it the heart of your computer? I mean, it couldn't be hard on your computer because like it doesn't have feelings, right? You just sometimes punch your computer for not working, right?
Right.
So it is not the heart of your computer. So, but before I talk about the main question, let's just talk about this point. Why food all around? Like, why am I so obsessed with food? And the reason with the food images on my slides is because, like, I think that CPU is just like a chef inside your computer, and it recklessly do all that the recipe is telling the CPU to do. So, uh, so you might wonder, so if the CPU doesn't think, and it's not the heart of your computer, then uh, who writes those recipes for the CPU? So, any ideas?
The software developer?
Yep, you bet. So a software developer, like who studied computer engineering or computer science, are those who write the recipes for the chef, which is the CPU, right? So let's get back to the main question. How does it work? Then if the CPU has the recipe, then how does it work? So I'm gonna give you pretty straightforward steps of how actually CPU follows the instruction which the a software developer has written, right? So first of all, the CPU would go to the hard drive and pick the instruction that is already put there. So CPU would bring the instruction and would follow the instruction step by step. Like it would start by reading the instruction and would brings the data from the hard drive. So, um, so like you might think, okay, we have the instruction in the hard drive, we have the ingredients, the data in the hard drive. So hard drive must be a very messed up place. Actually, it is. So, like organizing the hard drive is very complicated topic. We might want to go over it in next lectures. But let me just like give you an example. Let's take a look at an example, which is like a very simple addition. So you open your calculator in your computer and you write 2 plus 2, right? So you put the number 2 in the hard drive and you give the instruction like addition. Then the CPU would go to the hard drive, would pick up the instruction, would just see and look for the number 2 that you just put in the hard drive. It would brings it up and it would bring it up and then put it in its desktop, and it would do the calculation on its desktop and then put it back in the hard drive. So I said desktop. So do you guys have any idea where and what is the desktop for a CPU? Like if you look at the figure, probably so there are three parts. So can you guess like which part would be the desktop for a CPU? Would it be the hard drive or would it be RAM?
RAM, I guess.
Yep. So actually, RAM is the desktop for a CPU, and the bigger the desktop is, the CPU would just handle all this stuff much easier. So the CPU actually do all this calculation and processing with the data, and after the CPU is done with the calculation and processing, it should put all the results back to the hard drive. And so beside the hard drive was the place for the ingredients and also the instruction, it is the place for the output data. So the so we are done now with the instruction. We have the output in the hard drive, and everything is all set up. So what will be the next step? Like we are going to go to the next instruction in the hard drive.
Okay, there's your 6 minutes, but you go ahead and finish.
So the CPU would go to the next instruction until halt. So so I bet you know what does halt mean, right? Halt means stop. So what do I mean by like next instruction until halt? So I may want to give you this example. So imagine that the CPU is searching through the instruction in the hard drive and just would see instruction, and the instruction is telling the CPU to stop. Then what do you think the CPU would do? Like, any guess?
Stop.
Yeah. So if the CPU stops after reading that halt instruction, then that would be the end for the CPU's day, right? Or probably CPU would look at the clock and would call it a day and go home, right? So the CPU would stop in two circumstances. If the CPU sees the stop instruction, or if the CPU's clock stops. Like if you have ever gone to market and tried to buy a CPU, then the very important specs of the CPU would be the clock rate. And the clock rate indicates how fast the CPU can work. It's like kind of like a dog year. Have you ever heard of the concept of dog year? It's like much faster than hours. So
Yeah.
the faster the clock of the CPU is, the faster the world in the CPU, the stuff goes on in the CPU's world. So, but if you just cut off the clock for the CPU, the clock would immediately stop. So I guess this is all the parts and all the steps that I wanted to cover for this lecture. And I hope that by so far this make a little bit more sense by now. And so I'm waiting for any questions. So what questions do you have?
I have a question.
Questions?
Yeah, I have a question. So so when the CPU get an instruction, he will go going on for the task. But when before the CPU gets a result, and I put another instruction to the CPU, what would the CPU do? Would the CPU stop the current task, move on to the next one, or he keep the next instruction, wait until the current job is done?
So you're asking about what happens if the CPU is in the middle of the instruction and you put another instruction in the hard drive?
Yes.
Okay, so that's basically the case that would never happen. I mean, the CPU doesn't let it happen. But we can imagine what will happen. So the CPU is in the middle of the task, and then you put another instruction. Then there's two cases would occur, right? Your instruction is more important than what the CPU is doing right now, or it is not. So if it's more important, the CPU would switch to your instruction, or the CPU would end whatever the CPU is doing, and then would go to the next instruction, which might be yours. So if I want to just like give you an example, it might be like you're reading a book and the pizza guy rings the doorbell. What do you do? Reading is more important for the pizza? That's a tricky question, right? So, or maybe you're reading a book and or you're in an online class and your 17-year-old daughter would just calls you. What do you do? And so I hope that answers your question.
Yeah, no, I'm sorry, I didn't even ask it. Go ahead, Wei Jun, I'm sorry.
Yeah. So we set like a priority to the tasks.
Yep.
So the CPU could decide which one would be to be done first and which would be the.
Yeah, so who decides what the priority is? Yeah, that was my question.
Yeah, so that's actually a great question, and I'm really glad that you bring that up. So again, the software developers, they decide which task and which instruction would have the higher priority. And so there's another topic in like computer engineering like courses that talks about task scheduling. And if you like to read more about it, just Google on task scheduling or I guess multitasking kind of stuff, which like either CPU does support multitasking or it doesn't. So if it supports, then you have to have some kind of table that indicates which tasks have higher priorities.
Okay. I have just one final question, if that's okay. So I'm not familiar with the concept of a clock being in a CPU. And I was intrigued by your analogy of its function, being dog ears. So can you tell me a little bit more about what the function, how a clock operates within a CPU?
Yep. So that's a very good point, and I wanted to cover it, but because of the time limit, I just prefer to cover it in the next lecture. But the clock is just like I can put it this way. So imagine that you just like open your eyes in a middle of the island, and you don't have any clock. So what do you do? So you just look at the sun and like you would think, okay, do I have to eat the lunch now or do I have to eat the dinner? Or is it the breakfast time? So you don't know anything, right? So the clock is kind of like exactly the same concept that the clock is doing for our daily lives. Like when you see at the clock, it's like 8 o'clock, it's the time to get out of the bed and go and take a shower, or when it's like 12:40, it's time for English class. So then the clock indicates what CPU should do right now. And if you just if the clock stops, then the CPU doesn't know what to do. And the faster the clock runs in the CPU, then the faster the CPU should work and behave, right? So imagine that instead of like every second would be a second, which might be funny, but imagine that every second is like a nanosecond for me. So I would just act much faster, right? So
the rate of the clock, is that something that the software developer um, establishes, or how does the rate of the clock get established or get determined?
yep, that's another great question. So the rate of the clock is basically there are some limitation for the like rate of the clock, and so a software developer can like change the rate, but there is some kind of boundaries, and it's not the CPU cannot go faster than like some limits. And those limits are indicated by the company that manufacture those CPUs. Because, I mean, you might have heard overclock, like the CPU got overclocked. It means that the software developer used higher clock than it should. And the CPU most of the time get warmer and warmer till the point that it burns itself, which is really funny. So so does that answer your question, Sandy?
It does. Thank you very much. And I'm going to stop the recording.